In today's lesson, we are going to be looking at properties of logarithmic functions. So this is going to be similar to kind of looking at power laws in a sense where we're looking at kind of playing around, expanding or changing our function based on some kind of rules or laws. So in our table here, we can see some of the properties of logarithmic functions. We see some of the basic ones. If we have log of base A1 equal to 0, then it equals 0, right? Because anything to the power of 0 equals 1. If we have the logarithm of any base and it's raised to, or then logarithm base a to a power, then it equals the exponent. So essentially this exponent comes down out front here if it's the same base. If it's the logarithm is the exponent, so a to the power of log base ax, then x is what it equals. So it kind of cancels out, you could think of it that way. And some advanced properties, right? If we have the log of any base and it's equal to two things multiplying, we can split it up as log of the base of log base b m plus log base bn. So we can see similar here, we split it up. So instead of it being a product, it's a sum. Same thing with division, we can split it up to be subtraction. And if we have the log of base b m to the power of n, this n can come in front. So we drop the n in front. So we just want to use these different properties to help us expand or rewrite some of our logarithms. So if we have log x over y, so we don't see a base, so we don't see a base, we can assume there's a 10. So in this case, log base of 10 xy, this can be rewritten as log base 10x minus log base of 10y. Right, so we just split this up into a subtraction, or into a into like a difference instead of a quotient. So subtraction instead of division. The next one, log u to the power of 4. We don't see the base 10, but we assume it's there. This would be the same thing as saying 4 log u. So this exponent comes down in front. Log base 10a root b. So we don't see any operation between the a and the b, but we can assume there's a multiplication in there. So we can assume that there's multiplication between the a and the b. So we can rewrite this as log base 10a plus log base 10 root b. Again, even though we don't see the 10 there, we can assume it's there. For the next one, log base 9 x squared y cubed to the power of 9. I'm going to simplify this a little bit first by applying the power rule. So I have log base 9 x 18 y, or not cubed, 27. So I just multiplied those exponents. I can rewrite this as log base 9 x 18 plus log base 9 y to the power of 27. And I can rewrite this further by bringing the 18 in front. 18 log base 9 x plus 27 log base 9 y. So I can rewrite it as such. Lastly, we might have expressions of multiple logarithms, and we want to rewrite it as a single logarithm. So kind of rethinking again, kind of trying to combine things to make it a little bit simpler. Right, so I could rewrite this, because the 3 is out front, that's the same thing as saying log x cubed plus log y squared minus log 7 to the, or z to the power of 5. So I could rewrite it like that. When we see addition between logs of similar bases, right? Again, we don't see any different base, so we can assume that it is 10. If we see addition, we could rewrite it as multiplication. So log x cubed y squared divided by, because of subtraction, z to the power of 5. That's how I could rewrite it. So kind of just working backwards in a sense. B, again, I can bring the number in front to the exponent. So log base 2x to the power of a half minus log base 2w to the power of a half plus log base 2q. I could rewrite this as log base 2. Because we have subtraction, that means we're dividing. So you could say x to the power of a half, or maybe say square root x divided by square root w. And then we're multiplying because of the plus, multiplying by q. So again, just different ways of rewriting it, using some of the properties to kind of rewrite expressions, either expand them or simplify them. Just kind of, again, the idea of just playing around and learning how to combine different things or different logarithms, or combine expressions, or rewrite expressions in a different way. Some of them will be helpful when we get into solving equations. So it is helpful to understand how we can rewrite some of these logarithms.